Hi there, in this video I'll be talking about solving linear simultaneous equations. Let's see how do we do that. Have a look at the set of equations here. We have ax plus by equal to 0, cx plus dy equal to 0. Here x and y are variables and a, b, c, d are integers. So the purpose here is to get the values of x and y that satisfy both the equations. There are three possible ways to solve simultaneous equations, and here in this video we'll be focusing on graphical method. The first question that comes to our mind is, when do we use graphical method? So graphical method is used when we need to understand the relationships between the lines of the given equations. Let's have a look how do we do that. Have a look at the first example here. X plus y equal to 10 and 3x plus 2y equal to 24. We need to get the values of x and y that satisfy both the equations. So first step would be to draw the graphs for both the equations. So have a look here. We'll be taking different values of x and finding out the corresponding values of y. Here the key point is put x equal to 0, find y, and put y equal to 0, find x. When we put one of the variables to be 0, that actually reduces the calculations. So in between you can take any other point. For the second equation also we follow the same method and draw another table taking different values of x and y and correspondingly finding out the other variable. This is the graph for the given set of equations. You can see here the two lines are intersecting at the point 4, 6. X equal to 4 and y equal to 6. So here the point of intersection 4, 6 is the solution for the given set of equations. That means this point is being shared by both the lines. It's common to both the lines. Have a look at the next example now. We have 2x plus y equal to 10, 3x plus 3y equal to 18. So here again we would be drawing the graphs for both the equations. For the first equation 2x plus y equal to 10, we take different values of x and find the corresponding values of y. So here again the key point is putting x equal to 0, finding out y, and then putting y equal to 0, finding out x. We apply the same method to the second equation also. We have a table here where we are getting three sets of values for x and y. Let's have a look at the graph now. Have a look here. This is the graph for the given set of equations, and you can see these two lines are intersecting each other at a single point, which is the unique solution, and the point is 4, 2. So point of intersection 4, 2 is the solution to the given set of equations. We can conclude now, if two lines are intersecting each other at any point x, y, that point is the unique solution to the given set of equations. In our next example, we have x plus 7y equal to 21, 3x plus 21y equal to 63. So here again we draw the graphs for both the equations. First equation, we have this table here where we are keeping x equal to 0 and finding out y, and y equal to 0 and finding out x. In between we take one more value. We apply the same method to the second equation as well. This is the table that we have. Let's have a look at what do we get as graph. Now this graph is different. In this case we are just getting a single line because the two lines that we got, they are overlapping each other. So here we say there are infinite number of solutions because there are many common points between the lines. So if the lines overlap, that means there are infinite number of solutions. We can now conclude that if the lines overlap and we only see a single line, there are infinite solutions to the given set of equations. In our next example, we have another set of equations where we have x plus y equal to 16 and 3x plus 3y equal to 30. So here again we draw the graphs for both the equations. For the first equation, here is the table. We just follow the same method. Again, the key point is putting x equal to 0 and finding out y, and then putting y equal to 0 and finding out x. For the second equation, again, we follow the same method and get another set of values. Let's have a look at the graphs now. Have a look at the graphs here. In this case, the two lines that we get are parallel to each other. That means there is no point of intersection anywhere. So because the lines are parallel, we say there are no solutions existing here. So there is no solution if the lines are parallel because there is no common point between the lines. So now we can conclude if the lines are parallel, there is no solution to the given set of equations. We can now review with the key points here. So first point is if the lines intersect at one point, the point of intersection is the unique solution. Second point, if the lines are overlapping each other, we only see a single line. There are infinite solutions existing. And if the lines are parallel to each other, there is no solution at all because there is no common point between the lines. I hope by now the graphical method is clear to you. So using this graphical method, we can solve different sets of simultaneous equations. I hope the fundamentals are clear to you. Anything you want to clarify, you can always write in the comments. I'll be happy to answer. Thank you. Have a good day.